Hello everyone. Welcome to Computational Methods in Engineering class. I am RAKESH, Assistant Professor in Mechanical Engineering Department. In this session, I am going to explain Gauss Seidal iteration method. In previous class, I explained Jacobi's iteration method. In this session, I am going to explain Gauss Seidal iteration method. This is a modification of Jacobi's method. Let us consider the equations a1x plus b1y plus c1z equal to d1. Second equation a2x plus b2y plus c2z equal to d2. Third equation a3x plus b3y plus c3z equal to d3. This is the equation 1. Is written as from 1 x equal to 1 by a1 into d1 minus b1y minus c1z y equal to 1 by b2 into d2 minus a2x minus c2z z equal to 1 by c3 into d3 minus a3x minus b3y. This is the equation 2. Here we start with the initial approximates, that is x naught comma y naught comma z naught for x y z respectively, which may each be taken as 0. Now substituting y equal to y naught comma z equal to z naught. In the first of the equations 2 we get x1 equal to 1 by a1 into d1 minus b1 y naught b1 y naught minus c1 z naught. Then putting x equal to previous approximation x1 comma z equal to z naught in the second of the equations 2, that means this y, that is y1 equal to 1 by b2 into d2 minus a2 x1 minus c2 z naught. Next, substituting x equal to previous approximations x1 comma y equal to y1 in the third of the equations 2 we obtain z1 equal to 1 by c3 into d3 minus a3 x1 minus b3 y1 and so on. That is, as soon as a new approximation for an unknown is found, it is immediately used in the next step. This process of iteration is repeated till the values of x, y, z are obtained to desired degree of accuracy. Here, the important observation is the most recent approximations of the unknowns are used while proceeding to the next step. See here in the x1 we use y0 z0. In the second one y1 we used previous approximation x1 and z0. In z1 we used x1 and y1. The convergence in the Gauss Seidal method is twice as fast as Jacobi's method. Second observation is Jacobi's and Gauss Seidel methods converge for any choice of the initial approximations. Here we taken as that is y x not equal to y not equal z not equal 0. The absolute value of the largest coefficient is almost equal to or in at least one equation greater than the sum of the absolute values of all the remaining coefficients. See here, in the first equation, a1 is greater than b1 plus c1. Here, b2 greater than a2 plus c2. Here, c3 greater than a3 plus b3. This is the procedure for solving uh, Gauss Seidel iteration method. Let us see one problem. Uh, this is the given problem, that is solve the by see here, this is the Gauss Seidel iteration method. The equations 2x plus y minus 2z equals 17, 3x plus 20y minus z equal minus 18, 2x minus 3y plus 20z equal 25. Now we write the set of equations in the form of x equal to 1 by 20 into 17 minus y plus 2z. Second one, y equal to 1 by 20 into minus 18 minus 3x plus z. Third one, z equal to 1 by 20 into 25 minus 2x plus 3y. For first iteration number 1, iteration 1, let us assume y naught equal to 0 and z naught equal to 0. Now substitute these two values in the first of the this equation. Let us assume this is the equation 1. We get x1 equal to 1 by 20 into 17 minus y naught means 0 plus 2 into z naught, that means 0. The value is 17 by 20. The value is 0.85. Next, for calculating y1, x equal to x1 comma z equal to z naught. Here x1 means 0.85, z naught means 0. Next y1 equal to 1 by 20 into minus 18 minus 3 into x means x1 0.85 plus 2 into z0 0. This value is minus 1.0275. Similarly, uh, for z equation, x equal to x1, that means 0.85. Next y equal to y1, that means minus 1.0275. Next z1 equal to 1 by 20 into 25 minus 2 into x1 means 0.85 plus 3y. 3 into y means minus 1.0275. This value is 1.0109. Next iteration 2. For second iteration 2. Here x equal to previous one, x equal to here for calculating x2, uh, y equal to y1, that is minus 1.0275, z, z equal to z1, that is 1.0109. Next x2 equal to 1 by 20 into minus 17 minus y means minus 1.0275 plus 2z. 2z1. Z1 means 1.0109. This answer is 1.0025. For calculating y2, in the place of x, write recent approximation of x2, that is x2 equal to 1.0025, z equal to previous z1 value, that is 1.0109, y2 equal to 1 by 20 into minus 18 minus 3 into x2, that is 1.0025 plus 3 into no, no, this is z. Z means 1.0109. This value is minus 0.998. For calculating z2, in the place of x, that is x equal to x2 1.0025 and y equal to y2 value is minus 0.998. Next z2 equal to 1 by 20 into 25 minus 2 into x2. X2 value is 1.0025 plus 3 into y means minus 0.998. This value is 0.998. Next third iteration. third iteration, for calculating x3, y equal to y2, z equal to z2. Y2 value is minus 0.998, z2 value is 0.998. Next, x3 equal to 1 by 20 into 17 minus y2, that is minus 0.998 plus 2z2, that is 0.998. This value is 1.000. Similarly, calculate y3. Y3 equal to 1 by 20 minus 18 minus 3 x3, that is 1.000 plus 2z2. 2z2 means 0.998. This value is minus 1.000. Z3 equal to 1 by 20, 25 minus 2x3. x3 means 1.000 plus 3y3 minus 1.000. This value is 1.000. Uh, let us see the iteration 2 and iteration 3 values being practically the same. Here x3 equal to 1, y3 equal to minus 1, z3 equal to 1. In previous iteration, uh, that x2 value is 1.0025, y2 minus 0.998, z2 0.998, approximately equals. So we can stop the iteration here. Hence, the solution of the given equations, that is x equal to 1.000, y equal to minus 1.000, z equal to 1.000. This is the answer for the given set of equations. I hope this is very clear to everyone. If you have any doubts, please post the message in chat box. Thank you for watching. Please do like and subscribe my channel for more updates.